Hi, I'm Dr. Frank Summers. Welcome to Hubble's Universe Unfiltered. If you've been with us before, we used to do Hubble's Universe in the auditorium where I was standing behind a podium. For this new format, we've moved into the studio and we're presenting it on a widescreen format. And what's most important, what's exciting to me, is that I get to present the astronomy and all this wonderful science of Hubble directly to you. We're going to present one story in each episode and it allows me to go into great detail. For our first episode, we're going to celebrate Hubble's 18th anniversary. Hubble was launched in April 1990, and here's a gorgeous picture of it hanging above the Earth's limb. Now, 2008 is Hubble's 18th anniversary, and for each anniversary, we generally find a gorgeous image of Hubble to release. Well, for this one, we went and we took 59 images. This is the largest press release we have ever done. 59 gorgeous images, and they're all of interacting galaxies. Galaxies that are coming close to enough of each other that they can actually distort each other's features. There's just so much visual goodness here. But before I get into that, I want to go into some of the details. Now, the details here aren't with galaxies, but they actually begin with stars. When you look up in the night sky, what you see is a star field. Okay, this is a wonderful star field. Here you can see the constellation of Orion. Now, it may make you wonder, just how far away are these stars? Well, our closest star is, of course, the Sun. But how far away is the nearest star? To give you an example, suppose that this baseball here represents our Sun. One of the nearest stars, Alpha Centauri, is also a star about the exact same size as our Sun. And now, how far apart would I have to put these two baseballs in order to show the true relative size and distance? Well, if this represents the Sun, I'd have to take Alpha Centauri. Well, actually, this widescreen format isn't wide enough. I'd have to take it out of the room, down the hall. I'd go out the front door. I'd go across the street to the parking lot, get in my car, drive to the Baltimore airport, get on an airplane, and fly to Houston, Texas. One baseball here in Baltimore and one baseball in Houston, Texas. That is the correct scale distance between stars in our galaxy. One baseball with the Baltimore Orioles in Camden Yards and one baseball with the Houston Astros in the Astrodome. The distances between stars are about 1 million times larger than the stellar diameters. Well, the same is not true for galaxies. Here is a representation of our Milky Way galaxy. We actually live inside the Milky Way galaxy, so we can't get outside of it to take a picture. So this is an artist's conception of our Milky Way galaxy. And it's composed of about 100 million, maybe 200 billion stars. Okay, 100 billion to 200 billion stars in our galaxy. And our nearest large neighbor galaxy is the Andromeda galaxy. This is a real image of the Andromeda. And it's also 100 billion, 200 billion stars, along with, sort of gas and dust that you can see along these spiral arms and these dark regions along in here. Those would be the gas and dust in Andromeda. Now, these guys, being composed of hundreds of billions of stars, are much, much larger than our stars. Our Sun would be a tiny little something way in here. They're about 100,000 light years across. Now, a light year is the distance light can travel in a year. So that means from one side of our galaxy to the other side of the galaxy, it would take light traveling at 300,000 kilometers per second, 100,000 years to cross it. Okay, that's a long time. But so 100,000 years for the size of this and about 100,000 light years for the size of this. The question then is, how far apart are they? Well, these two galaxies are about 2.5 million light years apart. I don't have to get on any airplane and fly anywhere to show you the scale distances. I can actually just show it you here on the plasma screen. So they are about 25 times further apart than their size of these two galaxies. That's relatively close. We had a scale of about 1 million for stars. We got a scale of about 25 for galaxies. That means galaxies are close enough together that sometimes they can get really close and actually collide. Here's one image of two galaxies, and you can see a nice spiral galaxy here, and this is a spiral galaxy, but it's seen edge on, and all that dust and gas, you can see that as a dust lane, sort of shaped like a pancake, right? Okay, well, this guy looks like it's about to smash into this guy. Okay, and here's another image where you've got one galaxy that looks like it's already smashed through. The galaxies have become close enough, they find each other's gravity, gravity pulls them together, and this one is actually smashing through the other. Here's an image where the two galaxies have actually already passed by one another, and you can tell that because you see these big long tails sticking out. We call these tidal tails, and it's due to the tidal force of gravity. Basically, it's the simple idea that the gravitational pull on the near side of the galaxies is stronger, and the gravitational force on the far side of the galaxies is weaker, and that stretches the galaxies out to cause these big, long tidal tails. There's actually tidal tails in between them, but those sort of merge together. So when the galaxies come back together, you get these big, long tidal tails stretching out here, and then the cores come back together. Because, the gravity of one galaxy knows where the gravity of the other galaxies, and they're going to eventually smash in together. When they do, they can become all mixed up, and here you've got a picture of two galaxies where you can still see the tidal tail stretching out, but you've got all this sort of stuff just mixing together, and what they do is they merge to form a new, larger galaxy. So, let me show you those 5 images all at one time. You can see they're sort of approaching, and they're smashing, and they've got the tidal tail development, and they're coming smashing together, and then they're all mixed up. And it sort of looks like a sequence. Now, wouldn't it be cool if you could sort of watch this galaxy collision sequence go through? Well, galaxy collisions take about 1 billion years, maybe 2 billion years to occur. So to go from the first to last would take about 1 billion years, and we just don't live that long enough to be able to watch it. But what we can do is we can use computer simulations. We can take simulated galaxies, put them on the computer, smash them together, and see if they form what we see here with Hubble. Here is one such computer simulation. And what we've done here is we're going to play through the computer simulation, and then we're going to pause it here. And we're going to show you how the simulated galaxies look a lot like the two galaxies that are just about to collide. So we turn time back on. The galaxy comes to buzzsawing through the other one. And if we pause here and rotate it around so you can get the proper 3D perspective, you can see it matches the second galaxy that we showed you. Then they go smashing through each other, and here's where you can see the tidal tails developing. They develop really quickly. And again, they match the third galaxy pair that we showed you. And as the tidal tails stretch out, the cores of the galaxy come smashing back together. Now, this one has to be rotated to a very oblique angle, and then you can sort of match the fourth pair that we showed you previously. And finally, as the galaxies come smashing together, the cores smash together, the tidal tails still there, still stretch out, you can see a pretty good match for the mixed up galaxy. When all the time, what you really, if you look at it from a different perspective, you get this great big S sort of shape with the tidal tails and the core of the galaxies. So we can see in this wonderful gallery of 59 galaxy interactions, what we're seeing here is not only just different stages of galaxy interactions, from the beginnings of galaxies colliding to the ones that are all mixed up, but it's also dependent upon the viewing angle on which we see them. From the simulation, you can see that, oh, if we rotate around, we can produce really strange shapes like the ones we see here, and all of these big long tidal tails and all of these, oblong shapes that we produce in these galaxy interactions. They're due both to the time at which we're seeing it and the viewing angle from which we see it. Now, there's one more cool thing about galaxy interactions. Now, take a look at this one. This one is one that's all mixed up. There's stuff all over the place, and the galaxies are just smashing through one another. And you would think, when these galaxies collide, what happens to the stars? What's really cool is that the stars don't collide. Galaxies may contain hundreds of billions of stars, but remember our baseballs, right? Their distances between them are 1,000,000 to 1. There's plenty of room between Baltimore and Houston for another baseball to pass through. So when the galaxies collide, the stars within them don't collide. What's really colliding is all the gas and dust. And those big gas clouds smash together, and they heat up and they collapse down. They actually produce these shock waves that produce a ton more of star formation. But let me not go into that today. That'll be a topic for another episode of Hubble's Universe Unfiltered. And I can't wait to tell it to you because it's a really cool story too. We'll see you then. Take care. Just so much visual goodness here. But before I get into that, I want to go into some of the details. Now, the details here aren't with galaxies, but they actually begin with stars. When you look up in the night sky, what you see is a star field. Okay, this is a wonderful star field. Here you can see the constellation of Orion. Now, it may make you wonder, well, for this one, we went and we took 59 images. This is the largest press release we have ever done. 59 gorgeous images, and they're all of interacting galaxies. Galaxies that are coming close to enough of each other that they can actually distort each other's features. There's 4. We used to do Hubble's Universe in the auditorium where I was standing behind a podium. For this new format, we've moved into the studio and we're presenting it on a widescreen format. And what's most important, what's exciting to me, is that I get to present the astronomy and all this wonderful science of Hubble directly to you. We're going to present one story in each episode and it allows me to go into great detail. For our first episode, we're going to celebrate Hubble's 18th anniversary. Hubble was launched in April 1990, and here's a gorgeous picture of it hanging above the Earth's limb. Now, 2008 is Hubble's 18th anniversary, and for each anniversary, we generally find a gorgeous image of Hubble to release. Hi, I'm Dr. Frank Summers. Welcome to Hubble's Universe Unfiltered. If you've been with us before,